I'm Susan.
And I'm Christine.
I'm a science teacher.
And I'm an ELA and social studies teacher, and we're here to talk about where does all the water go, specifically talking about watersheds in Southwest Michigan. So Susan, I know that Michigan, much of the lakes, the rivers, especially the Great Lakes, have been constructed from glaciers and runoff from the glaciers, and that over time, the different valleys and hills have been constructed. Past that, I don't have a lot of knowledge on this subject, so I'm really interested to hear more and see maybe I know more than I think I do. Love to hear the science behind it.
All right, well, glaciers are pretty cool. They're these giant rivers of ice. The point is they're very big and they're very heavy. So when you have a mile or two of thick ice moving down a mountain, it's going to move lots and lots of sediment. It's like a bulldozer traveling down the mountain. Over time, it's going to sculpt and shape the land as it goes, wearing away things. And when it melts, it's going to leave evidence behind of its passing. So there's going to be long moraines, mounds of rocks and soil along the top, the sides, and at the front end where the glacier stops moving forward. Michigan's glaciers finally melted about 10,000 years ago, and they left behind all of the hills like you were talking about, composed of all this glacial sediment, bits of rock and sand and sometimes great big rocks, and features like drumlins, which are like teardrop-shaped hills, and kettle lakes, swales and swamps, big plains full of rocks and sand. So glaciers formed all of these landscapes that we see all across Michigan. And in fact, these lakes and the glacial meltwater that fills those lakes are kind of the headwaters of all the rivers that form the Great Lakes watershed.
So it seems like rivers form the heart of the watershed. So water has to move from a higher elevation because gravity, and it moves to the lower regions, and then pools and lakes or other rivers that leads to more lakes.
Yeah, water's all connected. I don't think people understand how connected water is. Water moves from high ground to low ground. That makes sense. Even though the slope might be very shallow, the rivers are going to flow. Those ridges on the side of a river, the high ground on the side, are called divides. And gravity pulls water down these slopes and into the rivers, which then flow toward a larger body of water. Even the Great Lakes have rivers that take the water from the Great Lakes all the way to the ocean. And so because this high ground sheds its water, the water runs from both ridges toward the middle. That's where watershed comes from, because the hills are actually shedding their water. And again, the river bottoms also slope downhill in some direction, even if only a little bit, and flowing water in small creeks and tributaries merge into these larger rivers. Eventually, the water from one watershed joins rivers from other watersheds, and you end up with a big giant watershed like the Great Lakes watershed.
Actually, I live very near the St. Joe River, which I know eventually ends up in the Great Lakes. I'm assuming that the St. Joe has other rivers attached to it, which then contribute to that watershed. Now, is a watershed always attached to a large body of water like Lake Michigan? Or can a watershed be smaller? For instance, is there a watershed around the St. Joe?
Absolutely. So most big watersheds like the Great Lakes watershed or the Mississippi watershed are composed of lots of very small watersheds. Watersheds can be all different sizes, but when we think of watersheds, we usually think of the bigger ones. Like the Great Lakes watershed encompasses all of the Great Lakes and all of the land around that eventually drains into the Great Lakes, from the smallest little stream to the bigger rivers like the Huron River or the St. Joe River. You were talking about the St. Joseph River, and the St. Joseph watershed is actually the third largest watershed contributing water to Lake Michigan. This watershed drains 4,600 square miles of land, and there's an elevation change of about 600 feet from its headwaters in Bob East Lake in Hillsdale County before it actually flows into Lake Michigan.
I never realized how long the St. Joe River was. I've been to Hillsdale County, I've seen parts of that, and I've never realized how far the river flows. There are a lot of little rivers off of it, so I never thought about it being the same river all the way throughout.
Yeah, 206 miles long and 1,600 miles of tributaries that contribute water to the St. Joe River all along the way. 1.5 million people live in the St. Joseph watershed. And what's a little dangerous for the watershed is that 70% of the land in the watershed is used for crop and animal production, which can tend to have a problem with water quality when you have areas that are so rich in agriculture and animal production.
Because of runoff?
Right,
things
right.
like that. Now, I know with like larger bodies of water, like lakes and ponds, and you have an algae problem. Do you get algae in rivers?
Oh, absolutely. Anytime you have runoff from fields or where animals are grazing and leaving their refuse behind, those byproducts are actually rich in nutrients. And when water runs off farmers' fields, it carries fertilizers into the rivers too. Now, when that gets to be too much, then you end up with algae growth and algae blooms, which can really cause a problem. So the St. Joe River flows a zigzag pattern west across southwestern Michigan in 3 rivers. The Rocky River and the Portage River join it. And then 3 miles further downriver, it's also joined by the Prairie River. So you have all these pretty major rivers joining in to form the St. Joe. From 3 rivers, the St. Joe River flows across southwestern Michigan. It kind of dips into Indiana for a bit and then comes back into southwestern Michigan and Berrien County. And it's a very meandering river. Now, a meander is a bend in a river. So when it's very bendy like that, it means the river has some age behind it. It's not moving very fast. It goes through Berrien Springs and finally reaches Lake Michigan between St. Joseph and Benton Harbor. And actually, about a mile before it gets to Lake Michigan, it's joined by the Pawpaw River.
We've talked a lot about rivers, but right at the beginning when you were talking about watersheds and the different things that were carved out by the glaciers, you said something about swamps. So do watersheds include more than just the rivers?
A watershed is actually all of the water in an area. When water slows down, sometimes even as rivers bend in these meanders we were talking about, when you have a slow spot like that, sometimes things like marshes and swamps will form. Sometimes when you have a lake, river flows into a lake or flows out of a lake, can also form wetlands and bogs, marshes, swamps. There's all kinds of names. They're pretty similar. It's simply a place where there is water almost all of the time. Wetlands have special soils, soils that have developed under wet conditions so they can support plant life. Most plants, if you leave them in water too long, they're just going to die. But the plants that live in swamps and bogs and marshes have adapted over time to live in those special conditions.
So by the sound of it, wetlands don't all look the same.
No, they don't really. They can look like swampy, like the Louisiana bayous with the big cypress trees and all the larger plant life. But wetlands can also look like grassy meadows or brushy fields. 75% of the wetlands in Michigan are actually areas in a forest where you walk between the trees and you're just sloshing through water. Wetlands perform a really important function when it comes to rivers. When the rivers get too full, they're at flood stage, flooding water comes into a marshland or a swamp, it slows down. So marshes can actually help prevent intense flooding because it just slows down that flow of water. It helps absorb that extra water so that flooding downstream the river is not as impactful. It soaks up the water rather than having that flood water move downstream. Wetlands cover about 5.5 million acres, or 15% of the land area of Michigan. That's kind of a lot. Unfortunately, about 50% of the wetlands in the St. Joe watershed have been lost, which is a little scary because wetlands play an important role in the ecology of a watershed. The slow-moving water and the high levels of nutrients is a great place for the growth and development of plants and organisms that make up the base of the food web and feed lots of the fish and amphibians that live in and around the lakes.
So I've heard wetlands referred to as nature's nurseries. What's this all about? I mean, I guess now that I think about it, when I walk by a swamp or especially in the summer, you hear all the different insects and the frogs and you see the cranes and the different wildlife. So I guess I understand there's a lot of animal diversity, but nature's nursery?
Many species of birds and mammals rely on wetlands for their food, for their water, for their shelter, especially during migration and especially when they're breeding. It's a pretty safe place for a lot of critters because it's not very hospitable for those that are not adapted to it. You know, one of the really interesting things about wetlands is that scientists now know that wetlands can also help to improve our atmosphere. Wetlands actually store carbon. The percentage of plants in a wetland is really high. Plants store carbon. And so when those plants die, they retain that carbon and more plants grow. And so wetlands and bogs can actually serve as a huge carbon store where carbon dioxide is taken from the air by the plants and then it's stored in the plants. And so wetlands actually can help to moderate global climate conditions.
This is why when we're talk about destruction of environment to make way for agriculture or cities and development, if you are destroying the wetlands, we're actually accelerating or contributing to these problems.
You're absolutely right. When they stir up a wetland or they fill it in, they've reduced the ability of that part of the world to take in carbon dioxide and help keep our atmosphere clean.
So I never realized the complexity and intricacy of watersheds and the rivers and the wetlands that are associated with our Great Lakes. I know pollution's a threat, that human impact is definitely a threat on these, but as you said, I don't know how many people realize the extreme impact on wetlands specifically.
We need to consider that all the watersheds and all the water within those watersheds can actually become a tragedy of the commons. Everybody has access, everybody uses it, and eventually there's not going to be enough clean, fresh water for any of us to use. And so I think what's important for us to remember is that there's a real burden of human activities putting stress on our watersheds, on our water resources, and that over time, we're going to really have a problem. So we all need to take tiny steps, and if everybody just did a little something to help protect our watersheds, our wetlands, to help preserve our water ecosystems, I think we can avoid our water in Michigan becoming a real tragedy of the commons.